My name is Vanessa Echeverria, and I am a postdoctoral researcher at Monash University, and today I'm excited to share our research on the lessons learned from a multimodal learning analytics deployment in the wild. Traditionally, learning analytics have focused on analyzing student interactions through online learning systems using data like mouse click and keystrokes. This approach provides limited insights because it doesn't capture the richness of learning that happens beyond the computer screen. Multimodal learning analytics is a new approach that aims to address this limitation. It goes beyond traditional methods by capturing a wider range of interactions in the learning environment. This includes how students interact with each other, with teachers, and with the physical space around them. MMLA can also leverage sensors to capture data on things like emotions, attention, and even physiological responses. This gives us a more holistic view on what's happening during the learning process. By using MMLA, we can gain deeper understanding of how people learn. This can help us improve teaching practices, create more effective learning environments, and ultimately help students achieve better outcomes. MMLA aims at crystallizing Marx-Weiser vision in educational contexts by creating learning spaces enhanced with ubiquitous computing capabilities to augment teachers' and students' activities. MMLA research has started to be applied to more authentic educational situations with in the wild studies being conducted across different learning environments. As sensing technologies have become more mature over the years, MMLA has experienced rapid growth on diversification, incorporating new modalities on data sources and exploring various application scenarios. For instance, wearable sensors, positioning tracing systems, and biometric sensors have become available for capturing spatial and physiological data, enabling the modeling of complex educational constructs. In recent years, MMLA research has started to be applied to more authentic educational situations with in-the-wild studies being conducted across different learning environments, such as early education classrooms, school libraries, open-plan primary schools, nursing simulation classrooms, and exhibition centers. This shift from controlled lab environments to real-world settings has revealed several significant challenges in incorporating MMLA technologies into routine educational practices. Most MMLA studies so far has primarily focused on developing prototypes and testing the functionality of different combinations of sensors and analytics approaches. Yet, many concerns have been raised regarding the logistical challenges that can emerge when moving from controlled settings to in-the-wild deployments, such as the added intrusiveness of sensing devices and complexity in their installation and orchestration. Those challenges are related to the complexity of sensor installation requirements, cost, and lack of technology readiness to enable full-scale deployments. Due to these logistical challenges, there is a lack of MMLA studies that have closed the learning analytics loop by providing some form of end-user interfaces, make it harder for educational stakeholders to weigh the benefits against the potential added complexity to their already rich educational ecologies. This can undermine teacher and student confidence if they don't understand how the MMLA system aligns with their teaching practices or learning outcome. Given the opportunities enabled by various sensing technologies, the privacy issues surrounding the adoption of MMLA innovations are the focus of critical debates. There is a need to consider the privacy implications of using sensing technologies to generate analytics. Also, students and teachers have expressed concerns regarding the security of their data. Additionally, while most of MMLA innovations endeavor to provide dashboards and visualizations for supporting educational practices, privacy issues regarding who has the right to see the visualizations remain unclear. Beyond logistical and privacy issues, the potential bias in analytics and cognitive dissonances that might be caused by the inconsistency between individuals' observations and generated insights could also undermine the potential benefits of MMLA innovations. Significant concerns have been highlighted regarding the need to enhance trust and data transparency within MMLA systems and in AI-powered educational technologies. Moreover, Yan et al. Suggested that more research needs to be done to assess the potential risks of making decisions with incomplete multimodal data. Understanding the ethical practices using these analytics is also essential but rarely considered in prior literature and requires the participation of key educational stakeholders such as students and educators. To address the challenges reviewed in the literature, we formulate the following research question. What logistical, privacy, and ethical challenges emerge from a complex MMLA in the wild study that closed the analytics loop by providing direct feedback to students? By analyzing our experiences, we aim to offer valuable lessons learned to researchers, developers, and designers. These lessons will assist them in making informed choices when deploying similar innovations that utilize technology like ubiquitous computing, sensors, and AI within physical classrooms to enhance learning. Inspired by human-centered interaction works, we explore the main logistic, privacy, and ethical challenges when designing and deploying MMLA research in the wild, organized around 5 main themes, such as space and place, data and analytics, human-centeredness, social factors, and sustainability. This project is situated in a team-based training simulation in nursing education. Teams should demonstrate effective communication, prioritization, and teamwork strategies to provide care to patients. 4 nurses participate in the simulation-based scenario in which they need to provide care to 4 dummy patients, enacting a role of a primary nurse or secondary nurse in a ward. Students are equipped with a microphone and a positioning tag to capture their audio and spatial data, respectively. Each student is color-coded to identify their role in the simulation. After the scenario, teachers led a guided reflection using the analytics to support their thoughts and spark discussion with students. This in the wild study had 2 iterations, the first conducted in 2021 and the second conducted in 2022. In the first iteration of the study, all participating students were asked to rate their perception of the intrusiveness of the sensing technology in the learning space. In addition, 20 students who participated in the first iteration also participated in 1-hour post-hoc individual interviews to explore their perceptions and experience more in depth in relation to the space and place, data and analytics, and social factors. In the second iteration, teachers used a set of analytics to support the reflection, which were automatically generated after the clinical scenario. The students who consented to participate in the second iteration were invited to participate in a survey to gather their perceptions on the trust of the MMLA dashboard using their own data. A total of 47 students complete this survey. 4 senior teaching team members and a total of 7 additional supporting teachers were asked to complete a survey immediately after each class. The survey gathered teachers' perceptions on the helpfulness of the dashboard into their learning experience. Moreover, 4 senior teaching team members participated in a post-hoc reflective interview session to gain insights into their experiences and challenges in using the MMLA dashboard in an authentic setting. We asked questions related to the 5 themes. Finally, 5 members of the research team, who were the ones mostly involved in the deployment, were asked to fill in a survey to reflect on and document their challenges and experiences. During the inductive analysis, 3 researchers collaborated to identify a total of 337 quotes from interviews transcripts and open-ended survey questions, which were extracted and assembled on a collaborative board for analysis and synthesis. Then, they organized all the quotes according to the 5 themes and inductively grouped similar quotes within each theme to discover emerging topics. We now present the lessons learned in relation to the 5 main topics. The first one is space and place. While students did not report discomfort in wearing the sensors, teachers can still get concerned about their potential distracting factor, and some students can feel stressed about being monitored. The lack of MMLA technology readiness can severely impact the lessons plan. Teachers need to play an active role to create strategies to moderate the sensing and analytics technologies and minimize potential disruptions and setup time. While several technical issues that can emerge during MMLA deployment are beyond the control of the research team, reducing the number of devices used can minimize potential technical failures. Multimodal data quality, at least currently, is a trade-off between capturing high-quality data and the portability and affordability of the sensing technology. Now, in relation to the data and analytics, if communicated clearly, students are willing to participate in a complex MMLA study and contribute their data for the purpose of helping their teachers or future students. Teachers can and need to develop strategies to optimize the use of multimodal data to support students. Although multimodal data is required to build analytical representations of an embodied learning experience, multimodal sensor data are intrinsically incomplete and subject to bias. Thus, mechanisms to ensure MMLA systems are trustworthy and designing for data incompleteness are required. Teachers need to be supported to develop relevant data literacy skills for them to develop pedagogical strategies around the effective use of the intrinsically complex MMLA visual interfaces. Students may also require visualization guidance for them to understand the meaning of the data in educational terms. For our third main theme, which is human-centeredness, teachers' appreciation of partnering with researchers in the design process can lead to creating MMLA systems aligned with teaching practices and learning goals. Involving teachers and students in the design process contributes to the validation of MMLA interfaces according to the learning design and to the improvement of the logistics of the MMLA research study. The fourth topic, which is about social factors, it is challenging to explain to students what a complex MMLA study entails. Providing too many technical details about the sensors and the analytics in advance does not necessarily contribute to clarity. Explaining the complexity of the deployment in person can enable students to ask clarification questions and then provide informed consent. Students were willing to share their multimodal data with others if their privacy is preserved and the purpose is limited to supporting learning. While most students see their multimodal data as only beneficial to themselves, some students can see the potential benefit to make their data available to other students to learn from their experiences or from teachers to improve the design of the learning task. As for sustainability, a potential strategy to maximize long-term technical sustainability is a lightweight microservice-based architecture that can enable attaching and detaching sensors as required. A potential strategy to maximize adoption and technology appropriation includes embedding sensing capabilities into the classroom, providing a high degree of user control, and providing training to teachers on system usage and data interpretation. Reflecting on the implications for practice, it is becoming critical to forge strong partnership relationships among teachers, students, educational decision-makers, researchers, and developers. By giving an active voice to students and involving teachers in the design process, we were able to identify the key practical challenges that can easily undermine adoption if they are not addressed in a timely manner. The data captured from the physical world through sensing devices are often incomplete, noisy, and unreliable. This means that the design of effective MMLA interfaces need to deal with data incompleteness and partial models of the actual learning activity. Creating MMLA systems that perform fully automated actions based on this incomplete data is risky and cannot be recommended at this level of MMLA maturity. MMLA holds a great potential for enhancing the support of teachers and learners, but with several challenges. In this presentation, we explore the challenges that arose in the wild study. Some challenges can be addressed by refining study design and logistics and adapted educational practice. However, other challenges call for a human-centered approach to design ethical sensing and analytics technologies. Thank you for listening to our presentation, and please reach out if you need more information.